Right, a few weeks ago I got a new scope, and included in the box was one of these levels, spirit levels that you can fix on the side of your scope. I've never used one before, I've always been a bit skeptical, and I didn't fit it initially, but it kind of got me thinking about the effects of a canted over rifle. So this is what this video is about. I can get a bit nerdy sometimes, as you can see here. So I've done some diagrams, illustrations, if you like, about the effect, what happens to the round, where it lands if we don't hold the rifle completely vertically. There's quite a few things on YouTube, but most of them explaining verbally the effects. So I think this is quite helpful to see what's going on here. I've done this extremely exaggerated loopy round. It's more like a sort of paintball or a archery thing, and I think it's roughly represents about 10 meters there. So it's not good for putting any numbers on, but it might be good for just seeing what's going on here. So if we look directly from the back of this scope, I guess you've figured out by now that this is this is representing a scope with the crosshairs, the crosshairs axis represented by this line, and the round trajectory represented by the red line there. The rifle is free to move around the crosshairs axis. So let's take a look directly down the scope, and if we line it up correctly, we can see that the round will fall in the center of the target. Okay, and so what happens if we're not quite vertical? You can see that a small angle has a huge amount. And it's also interesting to note that when you're talking about a very loopy round with a high point in the middle, or would that be apogee or something, when you're talking about a round that's flying like this, then the effect is mostly in the horizontal. Clearly, if we tilt it a ridiculous amount, then the round starts to drop off. And if we take it to the extreme, where the rifle is lying on its side and there is no longer any vertical component, gravity just takes a hold immediately and the round drops away to the left-hand side if we tilt the rifle to the left. So that's obviously highly exaggerated, but I think we can see that the amount that the round is offset would be proportional to the height of the highest point in the middle there. We can take a look at a faster round. Again, we've got a different representation of the rifle here, but it's much faster round, much flatter, although still quite a height in the middle. And as we can see here, a small amount of cant produces much less of an error. And we can see that it starts to drop away as well. A little bit of horizontal movement, but it's still basically, sorry, I should have said a little bit of vertical movement. It's basically horizontal movement, and when you start to get to more extreme tilts, then once again the round will drop away. Okay, so that's all interesting, or not. What about looking at this a different way then? As you can see here, the rifle is rotating around basically the crosshairs axis. That's not necessarily the axis of the scope, but it is the axis of where the crosshairs is. It could even be a laser red dot would be the same effect here, but basically, as you can see, we're rotating around about this optical axis. Let's look at it in a different way. If I can find the right piece, here we go. Getting a bit more sophisticated here. Here we've got a slightly better representation of a rifle, although this is actually an old 2.2 rimfire. This is a BSA Martini that I screwed up years ago by shortening the barrel and adding this thing for a scope. Anyway, makes a good representation for us here. So the blue line representing the crosshairs axis again, the yellow thing representing, in this case, a mythical round that weighs nothing, so not affected by gravity. So this is shooting completely horizontally and ends up in the center of this target, which in this case is accurately 50 meters away. And in this case, we've actually fixed the barrel in space as if it was in some invisible lathe, so that let me unfix this. Okay, so the rifle, as you see this time, is rotating around the barrel. So the scope is basically rotating around that axis instead of the other way around. So what's the advantage of looking at it like this? Basically, I think you'll understand that when we fire a real round, it will drop however far it drops, and it will hit the fence over there at 50 meters, and it won't make any difference the angle of the rifle here. As long as we've got a straight barrel and a good crown, we can rotate that around the bore axis and it won't make any difference to where the round lands. So although I've illustrated this with an old 2.2 rimfire, the numbers I've done are the same as before with a 2.2 12-foot-pound air rifle. So what's happened is, let me just straighten this up more or less. Actually, let me put it properly vertical, just so we don't get confused. Is that absolutely vertical? No, it's 3 degrees. Okay, so now it's vertical, 0 degrees. So we fired a genuine round, and it's made a hole in the fence. Where's the fence gone? It's made a hole in the fence, and we've stuck a target over the hole, exactly on the bullseye. We've then adjusted our crosshairs axis so that it falls directly on the bullseye. So basically, this rifle is now zeroed at 50 meters. As before, or maybe I didn't do that. No, actually, the drop for a 2.2 12-foot-pound, probably most of the calculators will give a similar answer, but according to mine, we've got a drop around about, that's an absolute drop from a horizontally fired round, an absolute drop of 478 millimeters. So here, fixed on the fence, take my word for it, these are 478 millimeters apart. This is the size of an A4 sheet. Yeah, so that's the absolutely horizontal line. that's where our pellet has landed. So on this occasion, what happens if we tilt the rifle? The cat's going to scream at me now. Here we go. So if we tilt the rifle over, let's just look directly behind it. So in this case, it's the actual line of sight that moves, and it moves in the opposite direction that the round would move, because obviously if we've got a bit of a tilt on, we'd readjust that fucking cat. We'd readjust our aim point to here, and therefore the round would go over here somewhere. So what's the advantage of doing it this way? Basically, it's easier to calculate, as far as I'm concerned anyway, because the line of sight simply rotates in a circle. I'm going to kill that fucking cat. Simply rotates in a circle around about the bore line. So we can put some numbers on this. So spreadsheet here, 12 foot-pounds air gun, there we go. 50 meters, standard weight of a pellet, ballistic coefficient around around about that. 3-degree tilt I've gone for here. We've got, so 3-degree tilt has given us a horizontal error of just about an inch. So let's say 24 millimeters. So what's the difference with a 177 12 foot-pounds? Going a lot faster. We've now got a horizontal error of just about half that, 12 millimeters. And it wasn't until I saw this that I really realised why the HFT people, the target people, go for a 177. And in fact, if I ever bought another sub 12 foot-pounds air rifle, this has convinced me enough that next time I would go for a 177. Let's have a look what happens if we've got 35 foot-pounds 2.2. Speeds are similar, so basically the error is similar. Got 11 millimeters there. 2.2 rimfire, 91 foot-pounds. Speed would be a bit higher, and a 3-degree cant error would give us about 7 millimeters. I've also got a 17 HMR, which are fucking fast. 777, and hence we've hardly got any error at all, 1.2 millimeters. Just out of interest, I added another bit to this spreadsheet. So what happens if we believe the range is 50 meters, but in fact we've miscalculated or misranged by 1 meter? The 2.2 sub 12 foot-pounds drops another 19 millimeters. The 177 just drops 11. Well, you can see the rest here, down to the 17 HMR that doesn't give a damn. 1 millimeter error. Well, I don't know. I found all that reasonably interesting when I was looking at all of this. I hope you have too, and I hope these illustrations help you to see what's actually going on when we cant the rifle over. It'd be interesting to see actually with a spirit level if that easily puts us within half a degree error or something, but of course we look up to our spirit level and then we look back inside the scope, so I don't know what's the normal error for a carefully placed shot. I should think it would still be around about half a degree. Anyway, I do hope you enjoyed this. Put your comments below.